In this lesson, and you may have already watched this video, we're going to be looking at quadratic formula. So the question that this video is going to answer is, where does the quadratic formula come from? Well, think about what we've done previously. We have solved things out using factoring, and we've solved things out using, completing the square. So what if I did completing the square on just a generic standard quadratic equation? So if I started with ax squared, so ax squared plus bx plus c. And let's set this equal to 0 as we usually do for completing the square. So what we usually do for completing the square is we first factor out our a value. So I factored that out of my first two expressions, which means I'm really going to have to divide it out. So this is going to be b over a times x plus c still sitting on the outside. Excuse me. So then our next thing that we did is we did our b over 2 squared. Well, our b value in this case is now this whole thing b over a. So I'm going to take b over a all divided by 2, and that gets squared. Okay. So whenever I divide something or divide fractions, it's really multiplying by the reciprocal of that second fraction. So this really comes out to b over 2a all squared. Well, let's see here. If I square those, that's going to give me a b squared and a 4a squared. And just like completing the square, this is what I'm going to have to add and subtract inside the parentheses, outside the parentheses. And this is going to tell me how I end up factoring later on. And that's very important. I don't think I can factor these expressions with weird fractions and not actually having any constants to work with. So let's keep going through our process. So I need to add b squared over 4a squared and subtract a times b squared over 4a squared. So let's start doing some simplifying. Here we go. First, I factor what's inside that big set of parentheses, but I've already done the work. That's where that b over 2a comes from. So this is really x plus b over 2a all squared plus c minus, well, if I'm multiplying an a and I have an a squared in the denominator, I can actually simplify this out a little bit to b squared over 4a. This whole thing equals 0. And again, I can't really do a whole lot of combining, but actually I could. So we haven't reviewed this piece yet, but whenever I want to change what one of my fractions looks like, if I want to combine my like terms, I need to multiply whatever that constant is I need to use in that denominator. I have to multiply it in actually numerator and denominator. And I want to have this denominator 4a to be able to combine with a c. So I'm going to take this as a c over 1, and I'm going to multiply both the numerator and denominator by that 4a. And again, essentially, I'm really just multiplying by 1. I'm changing what the fraction looks like. I'm not changing the value. So we're going to do 4 times a times c all over 4a. And now that's subtracting b over 2 over 4a, or b squared over 2. And now I can actually combine those fractions, which is nice. Okay. So just copying down. So I can do 4ac minus b squared all over 4a now. Okay, so now I have one big fraction. Let's start moving things away, because again, the whole point of completing the square and solving by completing the square is to get that x by itself. So I need to move things away from the x now. So let's see here. That means first I want to move that big scary fraction. So we're going to subtract that from both sides. So negative 4ac minus b squared all over 4a. But actually, you know what? I'm going to rewrite that. Plus b over 2a all squared. If I multiply that by a -1, that's really multiplying everything in the numerator by a -1, which means I can flip-flop all my signs. So I'm going to do b squared and then a minus 4ac. Anything starting to look a little familiar? Let's see here. So I'm still trying to get the x by itself. That means I need to move that a. I'm going to divide that on both sides. But I already have a division on the right-hand side. So that means, well, if I divide by an a, that's actually going to put an a squared in that denominator. Okay. So b squared minus 4ac all over 4a squared. Looking familiar yet? Okay. I got to get the squared away. So I'm going to take the square root of both sides. Here we go. No more squared on the left. When I take the square root, how many answers do I have? So plus or minus square root b squared minus 4ac all over 4a to the squared, all under that square root. But wait a second. 4a squared, 4 is a perfect square. A squared is a perfect square. I need some more room. Let's go over here. So still haven't done anything with that left-hand side all that much. But on the right-hand side, I'm going to simplify that denominator. The numerator, I've got b squared minus 4ac. If I take the square root of 4 and the square root of a squared, that leaves me with 2a. And hey, I'm noticing I have a 2a in the denominator on that other fraction. So now if I start moving things, I'll be able to combine my terms. So let's move this b over 2a now. So I'm going to subtract that from both sides. We still have this plus or minus square root of b squared minus 4ac all over 2a. And both of these fractions now have the same denominator, so I can actually combine my numerators. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that, ladies and gentlemen, is our quadratic formula.